Hi, my name is Jürgen. I'm the scientific coordinator of the Leibniz-ScienceCampus Tübingen, and I welcome you to this talk entitled What's Cognitive about Cognitive Interfaces. The talk is part of an online event celebrating 10 years of research that was conducted in the Leibniz-ScienceCampus Cognitive Interfaces in Tübingen. However, before I begin, here's a short disclaimer. If you found this video on YouTube, I would recommend switching to our website cognitiveinterfaces.de, where you can see various other videos that were part of the online event. For instance, there is a virtual ceremony where you can see a video of an opening address and several more videos extending words of welcome about this 10-year research activity. And there is a virtual symposium where you will find this talk as well as many more videos on the scientific part of the Leibniz Science Campus. This includes a keynote talk from Christian Kieli from the University of Tampere in Finland, which was held online on May the 15th in 2020, as well as 16 videos on the current projects of the Science Campus. Okay, after this quick tour through the website cognitiveinterfaces.de, here is what you'll find in this talk. I will try to summarize 10 years of research in the Science Campus Tübingen, which is an interdisciplinary research network currently consisting of 16 projects from fields such as psychology, computer science, education, medicine, and others. In summarizing this research, I will look into the past, the present, and the future. From 2010 to 2016, the past, the Science Campus ran under the topic of informational environments. From 2017 to 2020, the present, the campus has been continued under the rubric of cognitive interfaces. The Science Campus will end at this stage, but of course research in Tübingen will continue, and I will address this with a glimpse into the future when talking about our next activities involved in human-agent interaction. The guiding question, especially when talking about the present and the future, will be what's cognitive about cognitive interfaces? To get a better picture of what this is all about, let's jump into the past. From 2010 to 2016, the Leibniz Science Campus Tübingen ran under the title Informational Environments. We began our interdisciplinary endeavor with the most basic of all questions in the social sciences. How do people make sense of the world that is surrounding them? Well, the most basic answer to this most basic question is that we make sense by interacting with our environment. The environment provides us with the necessary information that we need to survive and to thrive. That's why we were talking about an informational environment. Now, what are the constituent parts of this informational environment? We have argued that the total informational environment of a person consists of various smaller informational environments from which we draw important information. First, there is a social informational environment which consists of the web of interpersonal relations an individual has. In other words, family and friends, but also people who hold dedicated roles for information transmission like teachers or doctors. In prehistoric times, the social informational environment was the only means to get an understanding of the world, by social interaction with the people that one knew personally. This changed with the advent of writing. Now information and knowledge could be stored in physical artifacts, for instance letters or books. This allowed information to be preserved across time, and with the invention of the printing press, it was also possible to spread copies of information and knowledge across the globe. In the early 20th century, a new informational environment arose, namely a medial informational environment, which consists of things like radio and TV. Now we had all-purpose devices where any kind of content could be accessed. The device was no longer the physical carrier, like a book, but only the mediator of information. That's why these technologies are aptly called media. And finally, most recently, our informational environments were enriched by a digital component that we can access via computers, tablets, or smartphones. In the first 7 years of the Leibniz Science Campus Tübingen, we investigated how people navigate through these multitudes of informational environments to make sense of the world surrounding them. For instance, one project investigated whether students who are enrolled in different university courses, a part of their social and physical informational environment, differ in their use of digital informational environments. Another project looked into how people find information about health issues on the internet, a part of their digital informational environment, before visiting a doctor's office, a part of their social and physical informational environment. Many doctors can attest to the fact that talking to patients who are informed, and sometimes misinformed, from prior internet search impacts their daily healthcare practice. So these are just two examples of what we investigated between 2010 and 2016. If you want to know more about these and many other projects that we conducted in the early stages of the Science Campus, I can only suggest that you enrich your physical informational environment by reading this book, which came out in 2017. Meanwhile, let's move forward into the present. From 2017 onward, we reoriented the Science Campus by starting to talk about cognitive interfaces. In order to explain what we mean by this, let's briefly return to our notion of informational environments. One thing that I did not mention so far is that the digital informational environment differs from the social or physical environments inasmuch as we cannot access the information directly. Rather, we get access to the digital environment by way of an interface. The term interface can refer to hardware which gives us access, for instance keyboard or mouse, and by software which gives us access, the way that, say, an app or a website is designed. Now, starting in 2017, we became interested in the design of interfaces, but not only from a technical point of view, but also from a social science point of view. And on this basis, we decided to coin the term cognitive interfaces. We are using this term to express our key assumption here. Human cognition is not only influenced by the content that we come across in the digital environment, rather it is the very design of interfaces itself which also impacts cognitive processes. This is the key assumption behind our research, and in the following parts of this talk I will try to substantiate this key assumption. More specifically, I will break down the key assumption into subsets of other assumptions. In particular, I will argue that our cognitive processes are influenced by whether there is information available or not, by what kind of information is available and not available, and by the way a given information is presented to us. We have referred to these three assumptions as questions of information design. Moreover, our cognitive processes are influenced by the way we can interact with information on an interface, and by the types of actions that an interface itself can execute. These two assumptions correspond to what we call interaction design. In the following, I will walk you through each of these 5 assumptions in more detail. I've called the first assumption mere availability. It means that the mere presence of information on an interface already has cognitive effects. There's considerable research tied to this assumption, under labels such as distributed cognition, the extended mind hypothesis, the so-called Google effect, or cognitive offloading. The gist of these various approaches is that one may regard an interface as a part or as an extension of a person's mind. More precisely, it has been suggested that when people have information easily available on an interface, they might save the burden of keeping this information in their working memory and rather offload cognition into the environment. However, this might come at a cost, as offloaded information might not be stored internally, leading to reduced memory performance when the external information is no longer available. In a nutshell, mere availability makes us smart when using the interface, but might be detrimental to later memory performance. The second assumption is about information selection. At any point in time, interface designers have to decide what information is made available and what information should be left out, as both screen size and human working memory capacity are limited. There are 2 facets to this assumption. The first has to do with the fact that early interfaces typically allow the user to see only one document at a time. However, for many complex tasks like higher order learning or decision making, it is useful to have simultaneous access to more than one document. In the picture on the right, you can see an interface for medical decision making on a large multi-touch table where one or more persons can simultaneously access multiple documents. It was speculated that such simultaneous access can have several benefits, many of which were foreshadowed in research about so-called multiple document integration. Among the assumed benefits of access to multiple documents are that people can better integrate multiple texts in memory, that they are better in detecting contradictions between different documents, and that they are better in resolving these kinds of conflicts. In sum, through interface design, the cognitive benefits of multiple document integration can be reaped. There is a second facet of information selection. Designers of cognitive interfaces can make the decision whether the information on an interface is only produced and curated by specialists, like journalists or teachers, or whether normal users may also contribute information. Examples of the latter would be content creation and revision on Wikipedia, writing customer reviews on the web pages of online vendors, or simply liking and sharing content on social media. It has been speculated that allowing for such user-generated content has enormous implications on cognitive processes, both for those who produce social content and those who consume social content. Producers of social content are lent a voice, a sense of agency, and the empowering feeling that they matter through their participation. But even consumers, those who just read product reviews or see the number of likes on an Instagram post, are cognitively affected. Through user reviews and likes, one and the same product or message may suddenly become more or less persuasive just because of user-generated content. In this way, cognitive interfaces can become instruments of social influence. While the second assumption was about what is shown on an interface, the third is about how it is represented. This should also have an impact on cognitive processes. I will discuss three facets of this assumption. The first facet refers to the specific combination of text, pictures, and sound on an interface. This is the core of multimedia research, where Mayer's theory of multimedia learning or Sweller's concept of cognitive load are still held in prominence. Among the findings in this literature, it was established that text with pictures generally leads to better learning than text alone, that an auditory explanation of a picture typically works better than a textual explanation of the same picture, and that the attention of a user can be guided through signaling devices, such as this virtual laser pointer. However, there are still gaps in these kinds of research and representation. For instance, there is comparably less research on how people learn from pictures alone. How do experts scan a picture? How do laypeople do the same task? And how can novices learn to scan pictures like experts do? For instance, it might be that learning to read pictures can benefit from proper highlighting techniques. Going beyond texts and pictures, the second facet of information representation that I'd like to address has to do with information richness. If you look at the two pictures on the right side of the screen, they both express laughing or happiness, but they differ in richness. One and the same content could be depicted realistically, for instance with a photo, or schematically, for instance with an emoji. The specific assumption here is that a realistic depiction might be more likely to elicit an emotional response, thus also impacting cognitive processes. Multimedia researchers have become increasingly aware of the role of emotion in learning and have argued that richness of information may impact emotion and subsequent processing. It is important to note that while richness in a depiction should elicit emotions, these emotions do not necessarily have to be positive ones. Seeing, for instance, a realistic depiction of a surgical operation might be more threatening to viewers than seeing a schematic depiction of the same surgical operation, and may therefore have an impact on the decision to undergo medical treatment. However, a richer and more realistic depiction of neutral or positive content, conversely, should be associated with positive emotions and therefore higher learning than a schematic and abstract depiction. In this case, interfaces with emotional design should be more fun for learners. Speaking of fun and entertainment, a third facet of representation on a cognitive interface is the inclusion of game-like elements. Research on digital game-based learning is one of the most active research fields in interface design, and lots of hopes are tied to the thought that learning might become more palatable when the interface includes game elements. In particular, it was proposed that game elements may lead to better learning outcomes through increased motivation and increased engagement. The three assumptions that I have talked about so far, mere availability, selection, and representation, all have to do with the way in which information on an interface affects cognition. We call this information design. The next two assumptions are about how the interaction between human and interface influences cognition. So now we're turning to interaction design. The fourth assumption directly centers around interaction, and it says that the way we can interact with an interface may have an influence on cognitive processes. I've broken down this assumption into two facets. The first facet is about research which investigates the role of touch displays. Touching objects on a screen may have different cognitive impacts than interaction via keyboard or mouse. Among scholars who investigated the role of touch interaction, you will typically encounter two lines of argumentation. The first line of argumentation comes from the research tradition of embodied cognition. According to this idea, the way we use our body is intimately tied to cognition. For instance, both children and adults often use their fingers when counting. Therefore, it might make a difference how much we use parts of our body when interacting with an interface. As touch interfaces are more direct and immediate than keyboard interfaces, it could be possible that they better support embodied cognition. The second line of argumentation about touch interfaces is based on so-called psychological ownership. According to this concept, we create a positive association between ourselves and an object when we touch this object. Indeed, some studies in consumer psychology have reported that we are willing to pay higher prices for products that we interacted with via touchscreen than for products that we interacted with via mouse. So in sum, there is ample evidence that using touchscreens for interaction impacts cognition. While touch interaction has become extremely commonplace, there are of course other types of interaction which are used much less frequently and may still have a strong impact on cognition. One example are virtual reality interfaces where people wear a head-mounted display which allows them to visually experience virtual worlds. Most people associate virtual reality, in short VR, with the depiction of worlds with physical properties, like walking through a virtual building or exploring a virtual planet. However, VR could also be used to navigate through semantic rather than physical space. Think about something like walking through your Google search results. Such a mapping of semantic objects to virtual space may also impact cognitive processes, for instance by helping learners to make sense of conceptual relations among abstract objects, and by seeing things, both perceptually and conceptually, from multiple perspectives. Therefore, when navigating through semantic space, learners might get a better conceptual understanding when interacting in the 3D environments provided by head-mounted displays versus the 2D environments provided by tablet computers. Summing up the fourth assumption, different ways of interaction, touch or 3D navigation, are likely to have an impact on cognitive processing. The fifth and last assumption, interface agency, is that human cognition is affected when a cognitive interface plays an active role. There are two facets of agency that I'd like to mention. The first is that by becoming active, an interface will elicit social behavior in a user. One very simple example for interface agency is instruction. With instruction, interaction control shifts from the user to the interface. When an interface instructs a user to perform a certain activity, most users have no second thoughts about following these instructions. This is quite fascinating, considering that these instructions essentially come from a piece of software. However, it is not really clear whether instructions from a computer are followed in the same way as instructions from a human being. Somewhat similar to giving an instruction is giving a recommendation. Many modern online services, whether it is an online vendor or a streaming platform, implement so-called recommender systems, which point their users to content that they might like. Based on a person's navigation history and the navigation history of similar other users, a recommender system tries to make educated guesses about the taste of a user and generates personalized suggestions. What is special about instructions and recommendations? First, both with instructions and with recommendations, a cognitive interface essentially performs a social role. With instructions, it is the role of a teacher or trainer, and with recommendations, it is the role of a friend who knows your taste and is an expert in the topic you are interested in. This kind of social agency might lead to better knowledge acquisition and skill acquisition in the case of instructions, and stronger social influence and behavioral change in the case of recommendations. Cognition is influenced when an interface takes on an agentic and social role. Last but not least, there is another facet of interface agency, and it comes through what I would call analytic interfaces. These are interfaces that are coupled with software which can take an incoming stream of data and perform computational aggregations and inferences on the fly. Ways in how to make use of these data are often subsumed under labels like visual analytics or learning analytics. Most analytic interfaces rely on machine learning algorithms where an incoming stream of data is automatically classified. These classifications can be used to assess or diagnose a certain state and make inferences and predictions. For example, with learning analytics, it is possible to infer and predict problems of understanding based on the navigation and interaction data of a given learner. The machine classifications can also be visualized on the interface, which is so-called visual analytics, so that human users can inspect the data in a way that is easy to process and provides new insights. Finally, analytic interfaces can also be used to modify existing information, thus creating entirely new information. For instance, imagine an interface that would be capable to be fed with the content of this talk and then could generate different versions of the talk, say one version for journalists, one for interested laypersons, and one for experts in the field. Again, it should be noted that the agentic activity of analytic interfaces has an essentially social role. The interface acts as an expert which can generate novel data on the fly, thus providing interesting insights for the user who interacts with the system and fostering creativity. So here again is the list of 5 assumptions. First, mere availability on an interface can already lead to cognitive offloading. Second, the selection of information on an interface, for instance providing access to multiple documents or including user-generated content, can foster multiple document integration, lead to cognitive empowerment and to social influence. Third, representation of information, for instance combination of text and pictures, different levels of richness, or the inclusion of game elements, have an impact on learning directly or indirectly via emotion and motivation. Fourth, interaction with an interface, for instance via touch or 3D navigation, can foster embodied cognition, create psychological ownership, and support learning from multiple perspectives. And fifth, when the interface itself becomes agentic, for instance by providing instructions and recommendations, or by performing analytics, this will exert a social influence and might help to find new and creative solutions. As it happens, each of these 5 assumptions have been addressed by one or more current projects of the Leibniz-ScienceCampus Tübingen. So on our website cognitiveinterfaces.de you can find 16 project videos from the Science Campus. You could either use the filter options on the website to navigate the project videos by general topic, interfaces for learning, medical interfaces, social interfaces, or you can watch the next slides from this talk, where I will briefly show how each of the projects is related to the 5 assumptions that I've introduced. The first assumption is about the effects of mere availability of information on an interface, which might lead to cognitive offloading, and there's one project about this topic. The second assumption is about the selection of information. I've discussed the beneficial role of having simultaneous access to multiple documents, and one of our projects addressed this topic in the field of medical decision-making. Moreover, I talked about the inclusion of user-generated content, which might lead to producer effects and consumer effects. There's one project on producer effects, investigating cognitive interfaces from a citizen science perspective. And there are 2 projects on consumer effects. One investigates the question whether people prefer positive or negative customer reviews on shopping portals, and the other examines whether seeing online comments with lots of likes or lots of dislikes has an impact on reader attitudes. The third assumption was about representation. I briefly mentioned learning to scan pictures, and the corresponding project investigates how students in dental medicine can be supported through interface design in their ability to detect anomalies on X-ray scans of the jaw. Another facet of representations was richness, suggesting that realistic depictions might be associated with emotions. In one project, it is investigated whether the medical decision of laypeople to undergo surgery will differ after seeing a video of a real surgical operation versus a schematic depiction of that operation. Somewhat similarly, another project compared a rich game-based environment for mathematical learning with a stripped-down and abstract version of the same game, looking at differences in elicited emotions. Including game elements was yet another facet of representation, and the hopes that game-based learning might lead to higher engagement and better learning outcomes is at the center of our keynote talk by Christian Kiely. The fourth assumption was about interaction. I mentioned 2 factors that are associated with touch interaction, one based on embodiment, the other on psychological ownership. Consequently, there is one project looking at embodiment, whether children can learn mathematics by using a finger-based app, and there is a project investigating whether touching objects leads to psychological ownership. I also mentioned how interaction in a 3D environment may help in understanding complex conceptual relations, which is a topic of another project video. Finally, the 5th assumption was about interface agency. I mentioned that humans surprisingly often let interfaces take control in interaction. But is instruction from a computer as effective as that of a human? This is addressed in a project which has developed an app that instructs patients with osteoarthritis in the hips on how to do certain exercises and compares this to a human trainer. Another facet of agency is when an interface gives recommendations. One project addresses a specific type of cognitive interface, namely a system that recommends other people in a business context, and the project analyzes how people might use such a system. Last but not least, I discussed analytic interfaces, which express agency by their ability to generate new data based on an incoming data stream. I briefly mentioned visual analytics, and the corresponding project investigates how one and the same piece of information can be used for quite different interpretive purposes as it travels across social media, and how these contextual adaptations and modifications can be visualized. I also talked about learning analytics, where a stream of learner data are processed in real time. The corresponding project uses machine learning to infer learner attention from bodily postures and gaze directions, which could then be aggregated and displayed on a teacher dashboard to get real-time information about the attention level in the classroom. And finally, I talked about machine learning to generate new pieces of information. The corresponding project tries to develop tools that could rewrite text by modifying the emotional tone of these texts. I will not spoil the detail of what we found in all these projects, except for saying that we found support for some of these 5 assumptions, but we also quite frequently found no support, which is an interesting result in itself. That wraps my discussion of what happens in the Science Campus in the present. In the third part of this talk, I will briefly address the future of what's going to be researched next in Tübingen. Again, I will ask, what's cognitive about cognitive interfaces? In fact, when we coined the term, we always had a double meaning in mind. I've already addressed the first meaning. An interface becomes a cognitive interface when its design impacts cognitive processes. A second meaning of cognitive interfaces is that the interfaces themselves are more and more likely to exhibit features and abilities that could be called cognitive or intelligent. I would argue that in order to exhibit cognition or intelligence, it takes three ingredients. The first is interactivity. An interface must be in a constant information flow between the user and the digital informational environment, providing swift responses to user input. This is already the case for most standard interfaces. The second ingredient, adaptivity, means that an interface must respond to situational changes in its environment. Of course, in order to adapt to an environment, the interface must be able to perceive the environment. This is increasingly the case. Via sensors, trackers, and the Internet of Things, interfaces know more about their users and know more about their physical informational environments than ever before, and they can flexibly adapt to what happens in these environments. The third ingredient of cognition or intelligence is agency. I've already addressed interface agency when talking about the 5 assumptions earlier. Interfaces that do not only respond to a user's input, but may also initiate an interaction by instructing a user, by giving recommendations, or by analyzing incoming data on the fly and acting upon these data, providing real-time visual analytics or generating new data. Having cognitive interfaces that are interactive, adaptive, and agentic will turn them into what is commonly referred to as agents. Of course, there are already some rudimentary agents. Here are some examples. First, there are writing assistants like Google Smart Compose. Building on artificial intelligence and machine learning, these agents can analyze the text that a person writes in an email and predict, often with astounding accuracy, what the person wants to write next and make appropriate suggestions. Then, of course, there are the increasingly popular smart speakers, systems like Siri or Alexa that users address via voice commands and that can execute tasks like playing music or changing the light in your living room. And finally, there are chatbots which actually can hold conversations with human users. Starting in July of 2020, the IWM will establish a research network called Human-Agent Interaction, investigating how human users interact with such more or less intelligent agents. Due to time limits, I cannot provide you with information about all projects, so I will just present a few examples. For instance, one project will investigate in how far agent-based feedback in a learning context may or may not interfere with self-regulated activities of learners. Another project will investigate agents that assist humans in writing activities, like the aforementioned Google Smart Compose. One potential problem is that these writing assistants tend to make suggestions for texts that are quite friendly in tone. Consequently, there could be cases where an email, which was composed with the help of an agent, sounds more friendly than the user originally intended. This could lead to a distortion in interpersonal impression formation. Finally, there are projects about situations where an agent directly communicates with a human. In one of these projects, it will be investigated whether humans who are given the task to describe pictures might differ in their language use depending on whether they believe to interact with a human or with an agent. More generally, the projects in the research network will be characterized by two broader questions. How does human-agent interaction affect human performance? And second, how does human-agent interaction affect human acceptance of an agent? Starting with human performance, I would argue that the human performance when interacting with an agent is affected by similar factors that I have described in the 5 assumptions earlier. In other words, availability, selection of information, representation of information, modes of interaction, and types of agency might play a crucial role. The second aspect, human acceptance, might be scientifically more challenging. Based on earlier research, I would argue that when a cognitive interface becomes agentic, exhibits interactivity, adaptivity, and agency, people are more and more inclined to compare this agent to other humans. And if that assumption is true, humans should assess agents on the same dimensions that they use when assessing other humans. According to social psychology, the two fundamental dimensions are competence and warmth. If it is true that we will assess agents on competence and warmth, this raises a number of interesting questions. And on the last regular slide of this presentation, I will just provide you with some food for thought and future discussions on this issue. To get you into the mood for this, I will start with some bold predictions. The first prediction has to do with the goal of creating agents that are perceived as competent and warm. Most people, both laypersons but also scientists in the field, believe that warmth is the more challenging of these two. However, I would argue for the opposite. Irrespective of the philosophical questions whether an agent really has competence or warmth, it might be enough to fake competence or warmth. And I would argue that it is more difficult to convincingly fake competence than warmth. This is particularly true in areas where humans are good at, like interpersonal communication. Let me illustrate this with an example. If an agent does learning analytics and generates an instruction that is tailored to the need of a learner, the learner will often not be able to assess whether the agent did a good job or not. But when an agent has a 30-minute conversation with the human can easily assess whether the agent did a good job or not. This could lead to quite detrimental outcomes. For that reason, my second bold prediction is that we will soon see AI researchers reach out to social psychologists how such detrimental outcomes could be prevented. As of now, these two research areas are almost completely unconnected. I will end this talk with a number of questions that could have started a discussion if the Science Campus event would have been live, but nonetheless provide some interesting food for thought maybe. Do we need or want human-like agents in the first place? Would you think that the task of building human-like agents is doable? And what will be the main obstacles along the way? Achieving good performance or achieving acceptance? We hope to find answers to these questions over the next years. If you'd like to discuss such questions with us, reach out to our soon-to-be-established research network on human-agent interaction, for instance by dropping me an email. Thanks for listening to this talk and enjoy the other videos from this online event.